Okay, we'll be continue our previous discussion about the system component. Just to recall that in the previous class, we have discussed about where the system call actually what is the role of system call over here. So more we will discuss in the subsequent sites. It is an interface through which the application program interacts with the make the service available from the operating system. We have for the system components, we have discussed for the process management, where we have discussed that there are two different kinds of processes. One is user process and another is the system processes, and I have given an example that how the different system processes are also executing in our system. We have discussed about the different system process management, like the thread that can be used for execution, and different process management techniques like process synchronization, process communication, and deadlock handling. This is only a brief on what is process synchronization, communication, and deadlock handling that I have. These are all one chapter actually. Will be one on topic actually. So we will be discussing those in detail in different topics, solving many problems as well. Right? So for the system components, one of the point that you have discussed is the process management. Now, the next component, system component, is the memory management. When you say the memory management, it is actually main memory management. Wherever in your book or in your slide, only memory is written, this says that the main memory, unless it is not being written explicitly that it is a secondary memory. Unless it is not being written explicitly, then secondary memory. Just a second. Okay. So we are talking about the main memory management. So main memory is large array of words or bytes having its own address. You have already read in your computer architecture, you might have read. Main memory means your RAM. RAM consisting of what? Actually, memory is consisting of, can be viewed as a two-dimensional array consisting of what? Bytes or a word. You have we have already know about the byte addressing, word addressing, all this. So it's either we access in form of bytes or we access the memory in form of words. Each of these byte or words have its own address. Whenever you store some value, each of these has some address. If you store say file has address. If you store integer, it has address. So every object that you store has an address. It is the largest storage device in the CPU. Largest storage device the CPU can access directly. Now we will say that the hard disk is there. See over here. It says that the storage device the CPU can access directly. What it says, while running your program, CPU can access two things. One is your cache memory. Second one is your main memory. So if you want to execute a program has to be brought from disk to the memory for execution. Therefore, CPU generates an address according to the main memory only. CPU generates an address according to the main memory only. If my main memory is 4 GB, so 2 to the power 2 into 2 to the power 30, 2 to the power 32. So CPU can generate an address of 32 bits. Is it understood? So CPU always have an access to the main memory. So it will generate an address according to the main memory, not according to the disk. So therefore we say the largest storage device the CPU knows is the memory, right? Which it can access directly. The operating system maps a program to be executed to absolute address by locating it into memory. What the operating system does, it will load the program into somewhere in the memory. The actual address where it is being stored is called the absolute address. That is the absolute address from which, or the effective address from which the value to be extracted. But that is also another address is called the relative address. The relative address is the difference from the base address. So anyway, that we will discuss later. Only you remember that a program has to be loaded to the memory, and that address is your absolute address where it is being stored. To improve the CPU utilization and computer speed, we must keep several programs in memory. If you want to make our CPU busy and the computer speed has to be enhanced, then we must keep multiple programs in the memory. However, due to space constraint, we cannot store all programs in the memory. In that case, memory management is necessary. We may not store all the programs in the memory because there is a constraint in the space. So CPU quickly switches between these programs for its execution. And that is where the memory management comes into picture. So memory management means it has to store which programs in the memory from the disk and which programs can be executed by the processor. So operating system is responsible for the following activities in connection with the memory management. So in connection to the memory management, what it does, allocate and deallocate memory as needed. Whenever needed by the processor, it will allocate the memory for a process or for some variables, and whenever it is not required, it has to deallocate it. If you declare some variables in a program and your program ends, automatically deallocates. But if you have given a command to allocate the memory explicitly, like dynamic memory allocation, then you have to deallocate by yourself. Correct? So the variables that you declare, array that you declare, these are being allocated by the compiler, so it is being deallocated by the compiler itself. So operating system memory management take care of that. Allocate and deallocate memory as needed. It decides which part of memory will be used by whom. So in memory management, one part says that it decides which part of memory will be used by whom. So there are multiple programs is there in the memory. Every program is given with a different address in which it is being loaded. So operating system decides in which part of the memory will be used by which of the processor, which of the program. Which are the next processes are to be loaded in the next in the memory. I have 5 programs over here, 2 programs finished, so some more programs will come into the memory. Now that will be decided by this memory management of the operating system, that which program will be loaded next to the main memory. Right? So this is the function of memory management. So first one is the process management. Now you have main memory management. The third important component of system component is the file management. File management, what you have, the computer stores information on different types of physical media like magnetic disk, optical disk, etc. How do you store our file? It will be stored on a disk. If you want to store it permanently, those will be stored on the disk. Maybe a magnetic disk, hard disk, optical disk, there it is being stored. Each media is controlled by a device such as disk drive, step drive, etc. Each of these media, the physical media that we have discussed, how these are being controlled? These are being controlled by disk drive, tape drive, etc. So each drive has its own characteristics. Each drive has its own characteristics or properties like access speed, capacity. Suppose you are going for a hard disk or a CD drive or floppy disk or pen drive or like that. So each of these devices have different access speed and different capacity. Even 2 hard disks may have also 2 different capacity. So each drive has its own characteristics and properties. the data transfer rate is different from one device to another device. The access method may be is different from one device to another device. For example, if I say magnetic tape may be a sequential access, whereas your hard disk may be a random access or direct access. So every device has different characteristics, but we have to store our file in that location. I have a file I have created in memory, but I want to store it on the disk. So we need a mapping from main memory to your disk. The operating system implements the abstract concept of file by managing mass storage media such as disks, tapes and devices with control them. So what operating system does? It implements the abstract concept of file by managing the mass storage media. So how these files can be implemented on these disks, tapes and devices and to control them. So we have a virtual or a abstract means of managing those. So files are normally organized into directories to make them easier to use. So we do not usually keep all the files inside one directory, rather we keep it in multiple directories so that it will be easier for us to locate. File management is nothing but controlling the number of users in what way they access the files. Correct? So file management is the process of arranging these our informations in different locations in form of files so that user can have ease of accessing those files. So operating system is responsible for following activities in the file management. What it does? Creating and deleting files, file creation and file deletion. Even if you want to delete a file, operating system file management comes into picture by releasing those space, making it available for others. So creating and deleting directory of an organized file, if you have a file organization where directory structure are present, so file management part of operating system is responsible for creating and deleting directories. Mapping files onto secondary storage device. So what it does, the files which you have created in your memory, how it can be stored in the secondary storage device. We know that secondary storage are different in nature, the characteristics have in nature. So how this file will be mapped into this secondary storage device, and whenever required, when you read it, how it will be read exactly, and it will come to the memory. Because the way you store the file is the same file. If I copy to a pen drive and I copy to a tape drive or a hard disk are in three different manners it will be stored. But while reading, I must get the same content. So there is mapping is required. And this is being given by file management. The next one is the I/O management. I/O management says that there are various types of I/O devices are there, input output devices are there. How these I/O devices can be managed? Now question is that why to manage these I/O devices? Because all these I/O devices are different in nature, both in operation and in their characteristics. They are all different in nature. How these I/O devices can be managed? If you look into the I/O devices, there are different types of I/O devices. If you categorize them, some are human readable, means we can read, for example, printer, monitor, mouse, keyboard from which the human interacts, the human readable. Some are machine readable, like disks and tape drives, sensors, controllers, actuators. These are how the data is being captured through the machine itself. So these are machine readable. And some are we say as the communication devices. Communication devices like modem, digital line drivers, these are communication devices. So we have various kinds of I/O devices, mainly we have categorized into human readable, machine readable or communication devices. All these devices have different characteristics and operation. The operation of a printer is different from a monitor. The operation of a keyboard is different from a mouse. The operation of disk drives is different from the sensors. So how these are being operated, how this will be managed. The differences in IO devices can be what? The data rate. The data rate means the devices have different data rates. Data rate of what? Transfer. For transferring, yes, there is a maybe. Oh, voice is breaking. Okay. There is is there any doubt you have? Somebody has raised your hand. Okay. Is it audible now?
Yes, sir.
Okay. So these devices, what you are using, they have differences like they may have different data rate of transfer. While transferring the data rate transfer of printer is different from monitor. Maybe the keyboard data transfer is different from sensors. And you know the slowest device among these is the keyboard, right? So data rate is different for different IO input output. The applications are different, the operations are different. The complexity of control, the unit of transfer, the data representation on these drives, and the error conditions, these are all different for different IO devices. So therefore, managing multiple IO devices is quite a cumbersome task or difficult task, and which will be managed by the operating system, and that part which manages this IO is called the IO management. So in IO management, what is the goal of IO? What is the goal of input output? User should access all devices in a uniform manner. So whenever a user is accessing, it should get all devices in a uniform manner. Devices should be named in a those should be named also in a uniform manner. The operating system, without the intervention of the user program, should handle recoverable errors. What it says? First, they should have a uniform naming, like every device has a unique number or something, but has a uniform. It is not that one is in character, one is number, something given. So it should have a uniform manner of naming, and we should have a uniform way of accessing those. The operating system, without the intervention of the user program, should handle recoverable errors. There might be some errors occur, and operating system could be capable of recovering from those errors, right, without intervention of the user program. The OS must maintain security of the devices. It must maintain security of the devices. So anyone cannot have access to any of the devices. It's not that anyone can have access. So how authentication can be given? Only the authorized user can have access to the devices. So the OS should optimize the performance of the IO system. So there are different IO devices. The operating system should be capable of optimizing this IO use, so that most of the users should satisfy by getting these input output devices. So this is the goal of the IO management. So what it in return operating system does? Operating system hides the peculiarities of specific hardware devices from the user. Every device is peculiar, is unique, but user should not know that accessing this keyboard or accessing this drive is different. I must just click on somewhere and I must get it. So Unix hides its IO peculiarities from bulk of operating system by IO subsystem. So it says in some of the operating system like Unix, they have a IO subsystem which handles the IO. correct? So what is this IO subsystem? IO subsystem consists of memory management components like buffering, caching and spooling, general device driver interfaces, driver for specific hardware devices. All these in a combination, it will be called the IO subsystems. So we have a special subsystem in Unix which handles these things. What it handles? Memory management components, general device drivers. Every device is a driver. So the general device driver interface, drivers for specific hardware devices. Some new devices for which the hardware has to be designed, has to be installed, right? And memory management is buffering, caching and spooling. Spooling, I have already told you in batch processing in spooling what it is, what it does. Buffering is buffer, buffer is what? A temporary memory is being kept between the source and destination so that the speed mismatch can be bridged. The speed mismatch can be bridged if you have a buffer memory. If I want to write so much of data and a text to write, the buffer will hold those data. It's a temporary memory. And caching is generally used for storing some frequently accessed items so that every time I don't have to go for accessing to the source, I can get it from their own system. So the memory management techniques also being for the IO subsystems are being kept inside this IO subsystem itself. So we have discussed what? Process management. We have discussed about memory management. We have discussed about the file management, IO management. Now we'll talk about the disk management or secondary storage management. Disk means the secondary storage. So secondary storage management or mass storage management, or we say it is disk management. So your data which is being permanently stored on the disk. So how the disk can be managed? As the CPU can access the data directly from main memory only, we need to store data and programs only in main memory. Try to understand over here. I have already told that CPU can have access to the main memory only. It generates address according to the main memory. So you may have hundreds or thousands of files on the disk, but processor is going to, CPU is going to execute those programs which are there in the memory. So because it has a direct access to the memory. So we need to store the data and programs only in memory. Then only it can execute, right? But this memory, main memory, is very small and it is also volatile in nature. Correct? Your hard disk may be 1 TB hard disk, but your memory, main memory, maximum of 16 GB or 12 GB memory only. So you cannot keep all this 1 TB data inside the 416 GB RAM. So main memory is too small. And besides that, main memory is volatile in nature. As long as the power is there, your data is there. Once it's lost, your data is lost. But disk is not like that. Even if your power is off, the data is present on the disk itself. Correct? So we store our programs in disk until loaded into the memory. Therefore, we store it in the disk itself and then use the disk as both source and destination for their processing. Correct? So what you do, if I want to copy from one location to another location on the disk, try to understand. From your hard disk, I want to copy a file from a location of the hard disk and store it in another location in the hard disk itself. But for that also we require memory. So I'll get the data from the disk to the memory. Then I'll go from the memory, it will be transferred to the disk. Is it understood? So what do we do? So we store our programs in the disk until loaded into the memory. And then use the disk as both source and destination for their processing. Correct? So disk can be used for storing the data and retrieve the data. But for storing and for retrieving, we require memory. Correct? So one is memory management, but disk management is also required. how the disk can be accessed. Correct? So operating system is responsible for following activities in connection with the disk management. Correct? What are the activity? Free space management. In the hard disks, some of the locations are occupied and some of are free. When you try to store a new data in your disk, so it must find where the location it is being free so that your data can be stored. A free space management has to be there. So which locations are free, which are occupied, it should be marked so that a new file can be stored. Whenever a file is deleted, those locations should be marked as free so that other files can be stored. Once a file is stored, it should be declared as occupied so that no other file can be stored in that location. So this is what free space management. Storage allocation. Storage allocation, if you want to store a file, then it must provide the location where the data can be stored. Every time we may not get a continuous memory from the disk to store our file. So in that case, our file will be stored in fragmented. It will be stored in different locations, right? So if it is being stored in different location, how to access it? So you must get some pointer kind of thing. There are different way of accessing these locations. So we must know. So whenever we are storing a file, we do not know what we do. We simply file save. We give a file name. It is being stored. But the task is there to store this file onto the disk in a free location, mark them occupied so that it can be accessed again. And those are also not in continuous nature. So how it is being done? It is done by the disk management of the operating system. And another most important thing in the disk management is the disk scheduling. Disk scheduling says I have to access the disk locations. Data are stored in scattered way in different locations of the disk. I want to access my file. So what is the order in which I must access so that I will have less travel time, less head movement. I will have less head movement because there are various files that I am accessing, different locations I am accessing. What is the order? What is the scheduling criteria in which I must access so that I will have the disk will take less time for accessing. One more the system component is the networking. So this is one of the facilities that is being provided by the operating system. What it says, in a distributed system, each processor has its own local memory and the processors communicate with each other through various communication lines such as high-speed buses or telephone lines. Try to understand. We are talking about a distributed system. I am not talking about a parallel system over here, but a distributed system. Distributed systems we have discussed in the types of operating system. Just to recall your knowledge, I will tell you that distributed system is a collection of autonomous computers. You will have a collection of autonomous different kinds of computers. They are being connected for sharing information, right? So every processor has its own memory, own IP. So own local memory and the processor communicate with each other through various communication lines. So how they will communicate? They will communicate through various lines. For example, the high-speed bus or telephone lines or wires that can be connected to connect this processor in the distributed system. So distributed systems vary in size and function. Some distributed system may have less number of processors and some may have a very large number of processors, and they do different functions. And they may involve microprocessor, workstation, mini computer, large general purpose computer systems, etc. In a distributed system, you don't know what is the collection of these systems. Some are microprocessors, workstations, mini computers, they are might be connected. correct? So the processor in the system are connected through a communication network which can be configured in the number of different ways. So in short, I can say in a distributed system is a collection of different types of computer, autonomous computers. Each of the computer are of different types. Maybe a workstation, mini computer, large. So they are different computers. But so as they are different, the nature of working is also different. But they are communicating the data over the network through some channel, through some wires, or through, that has to be connected through communication network. But so even if the data has to be transferred, the data must be decoded in the other end. Suppose a microcomputer or a mini computer is transferring data to a workstation. So format is different, for two different from the source and destination, and it is being communicated through a communication network. So how this coding and decoding will be held? The network may be fully or partially connected. Not necessarily that all computers or all processors are directly connected to all other processors. If a processor is connected to all other processors directly, that means there is a edge, there is a path, sorry, there is a edge, or there is a bus, or there is a communication network directly from every one node to every other node, then we say it is a fully connected. If it is connected through any path, not by edge, then it may be some partially connected network. So the communication network design must consider routing and connection strategy. So if it is not being fully connected, so we must give a mechanism that how a particular node will be connected to other nodes. Correct? So the communication network design must consider routing and connection strategies and the problem of connections and security. Is it understood? We have a number of computers. They are being connected through through a network. The computers are different in nature. So while I think these computers are connected through a backbone network, right? That they may be fully connected or partially connected, but however that it must be connected, we must give a mechanism that what is the function it should use so that it will communicate to another node. That is the routing function and the connection strategy. A distributed system provides the user the access to the various resources the system maintains. The distributed system provides the user with the access to the various resources. So in a distributed system, many computers are there and each computer has some resources. So the networking operating system must provide how these resources which are present in different computers can be available to a particular computer. Correct? So access to a shared resource allows computational speed of data availability and reliability. If you could able to access those resources, my reliability or availability increases. That means if there is a failure, I can get data from some other location because I can have access. So it's a reliability increases. Availability, data is available everywhere because the data can be transferred. Example is your ATM network. You go with your ATM machine, wherever your data may be, wherever your account may be, you can have access to those in that ATM. So availability increases, reliability increases, the computational speed of also increases because of what? Because of this management or network management of the operating system. So one more system component is the protection system, which is being provided by the operating system. It is a mechanism which ensures that the files, memory management, CPU and other resources can be operated only by those processes that have authorization from the operating system. Even if you have access to this file, memory, CPU and all this, but you should have an authorization from the operating system. Operating system must authorize that this user can have access to this memory or this user can have access to this file. If the permission is not there, the file cannot be accessed. So how this can be implemented? How will you know that this file permission, this is the file, he is the file owner and he has to give the permission, he or she has to give the permission. So it refers to a mechanism of controlling the access of programs, process, users to the resources defined by the computer system. So there are some resources and there are some processes which are being used by users. So it says that which user is authenticated to use which of the resource or which process. If I am running a process in a system, in a multi-user environment, I am running a system program in a system, another user is running a process in the system, I should not have access to the process what the user 2 is running. So which resources or processes must be accessed by the different process users. So this access mechanism has to be controlled, has to be monitored, and that is the protection system. The protection oriented system provides a means to distinguish between authorized and unauthorized users. Who is the authorized user? Who is the unauthorized user? So if it is an unauthorized user, it should not give access and give the appropriate warning message or error message over there. It must give the appropriate error or warning message. We have also the command interpreter system. Command interpreter system means we must give the operating system provide some mechanism so that we must give some commands and we can get some output from there. Which commands, that we will discuss that what are the commands over there, but the operating system must provide an environment for the user to give some commands so that I can get the result immediately. So command interpreter is the interface between the user and operating system. How will you know what is going on, what files are there? To get those information, so it needs it's like a interface between the user and the operating system. It allows direct command entry. I'll give the command, I'll get the result immediately, right? So some operating system implements command interpreter in the kernel. In the kernel, they will have a command interpreter. The operating system such as Unix, DOS treat command interpreter as a special program initiated when the user logs on. So what it does, whenever the system logs on, a Unix or MS-DOS logs on, after login you will get a prompt, maybe a dollar prompt or a C:/ greater than like that prompt you will get. So prompt is the place from where you can give the commands. It allows the user to write the commands, right? So this program is known as the command line interpreter. The cell that you get C:/this or the dollar symbol that you get, these are command line interpreter or control card interpreter. And this is sometimes known as the cell of the operating system, because here only you will get, you will give the your command and you get the result. The function of command interpreter is to get the next command and execute it. So what it does, it is nothing to do. You have a set of instructions are there, set of commands are there. It will get one command, execute it, go for the next command, execute. So it will go on scanning the commands from the file and go on executing it, right? So operating systems are differentiated due to the difference in cell, because they do have different cell. Unix has different cell, MS-DOS has different cell, and the Macintosh operating system has different cell. The command statement themselves deals with what is this command, which type of command we will type over there in the command interpreter. Those commands are related to what? Maybe a process management. I want to know that how many processes are running. I'll write ps minus l. So one command, suppose it is there, ps minus l minus el, so that it will give you list all the processes that are running. Are you getting me? So in command prompt, in the dollar prompt, whatever. So it is the command line interpreter. There only I can give some commands. Which type of command? Command related to what? Command related to process management, memory management, secondary storage management, IO management. For these commands, for to acquire this status of this, I will give some commands. For example, I want to get the process. What are the processes are running? So I'll write PS minus EL. So you'll get what the processes. So these commands statements are related to what? Process management, input output handling, secondary storage management, main memory management, file system and access protection and network. That means till now whatever functions with the system components we have read, all the related commands to these systems can be executed through the command interpreter. So it is just provides a means through which we will give the commands and we will get the output over there. Besides this command line interpreter, it also provides the graphic user interface. Graphic user interface is quite user friendly as compared to the CLR, command line interface. These are user friendly desktop metaphor interface. We usually use the mouse and keyboard and monitor for the purpose, because in a graphic user interface we may require a pointing device. The icons represent the files, programs, actions, etc. So the icons that you see on your on our screen, what are those? Those are for either a file or a program or any action to take place. Those are being kept as the icons, right? So various mouse buttons over objects in the interface cause various actions. It says that the various mouse button over objects. So if I right click, I will get different values. If I have a left click, I have different value. If I double click, I will get different. So there are different actions on a particular object itself, right? So this provides information, options, execute function, open directory. All these are being can be we can get it from the graphic user interface. This graphic user interface is generally first invented by Xerox PARC PRC. Many systems now include both CLI and GUI interface. You go for many of the operating systems where you can go for CLI interface as well as GUI interface. Either you type commands to execute or you can run it, graphic user interface. The Microsoft Windows is GUI. Microsoft Windows is GUI with CLI command cell. If you look in Windows, Windows is CLI or GUI. Windows is GUI, graphic user interface. But however, you can type command for execution. You can go for Windows run and there you type CMD command CMD, so that you will get a prompt. And you go on typing some commands, you will get the output immediately. So therefore, Windows provides both CLI and GUI. Similarly, in lab, which operating system we are working with? We are working with Linux operating system. It provides GUI or not? It provides GUI because you have graphic user interface. Besides that, it also have a prompt, $prompt, where you can type some commands and you can also get. So Unix and Linux have CLI and GUI interfaces. What is the difference between command prompt and Windows PowerShell? See, in command prompt, actually we can only type some command and we will get the result, that much. But here it doesn't allow you to write codes for the system, for Windows programming. That is not being provided over there. Like you have in Unix operating system, we have a shell where you can write some programs and commands. That is not there in Windows. And for that only we have small API, Windows PowerShell is there. So where you could able to write some Windows programming, Windows API programming. But this is not exactly the same as of the Windows prompt, right? Just a second. So we are talking about the CLI and GUI. Okay, so did you get Prabhu Darshan? What is the difference command prompt and Windows PowerShell? Command prompt is just to get, will give some command over there and I'll get the output over. But I cannot program it, right? If I have to program for the Windows and write some code for the Windows itself, then I have to have for Windows PowerShell. I may go for this. It's a kind of additional API kind of thing which is being installed.
Okay, sir.
Okay, but in Unix or Linux, you have a cell is given where you can write some program, right? Similarly, you can have in Mac, Apple Mac OS is having a Aqua GUI interface with the Unix kernel, right? Okay. The system call I have already told you, but I will give one example. Maybe this I will discuss in the next class. The system call, and I'll give with an example that how different system calls will get executed. Okay, so if you have till now, if you have any doubt, you ask me till the time. Let me take the attendance first. One, number two is always absent. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25 is absent. 27, 29, 29, 30, 37 is not there. 39. Let me call the absent roll numbers. Roll number 2, 20, 22, 25, 27, 30, 37, 39, 73. Okay. 14 present, somebody says. Okay, 14 I have not called. Anybody having any doubt? Okay, then I'll end the session then.
Thank you, sir.
Thank you.